Hey, welcome back. This is Ben from Dorset Design Build with another PRS Fusion 360 video. I recently got a request from a viewer, Bake Shop Guitars, to see how I do the cam for my inlay technique. So I figured I'd jump ahead and do a fretboard cam video that includes the inlay but also includes radiusing the fretboard and doing the fret slots. So here is video number 11, Fretboard Cam. So first I want to go over the order of operations for cutting this fretboard. So I've got a fretboard set up here, and if I double click on it, you'll see if I go to the stock tab that I've picked the stock from a solid. And what I do there is I'm actually using a manufacturing model. And what that is basically it includes the model from the cam side, but you can also add add whatever you want as far as additional changes to that cam design. And you won't see these additional changes on the design side. So this is nice when you need particular things that are really just cam related. So one of the things I like to do sometimes is to actually draw the stock out manually, and then you can specify the stock that way. So I have a piece of wood that I drew out that is 3 inches wide, it's 20 inches long, and it is 1/4 of an inch tall. So that's my fret stock. So going back to the setup here, I'm going to collapse this down. Actually, if I click on fretboard, you might see that, as you click from these setups from one to the other, a lot of components are becoming automatically hidden. The way you do that is to use this synchronize feature. So basically, it's synchronizing the visibility of components. So you go to your setup, go up to your manufacturing model and hide the stuff you don't want to see in a particular setup, and then do a sync. So this way, when you're going back and forth in these different setups, you don't have to go up to your manufacturing model and hide all sorts of stuff. So that's a very convenient feature. But again, in the fretboard setup, the stock, I use this fretboard stock. Other stuff that I did in this setup, I set the work coordinate system to the center top of the stock. And so that's all pretty standard. I use the stock box point, and then you actually click on this and pick any of these box points. And the rest is pretty self-explanatory. Verify that your stock is what you need here in stock dimensions. Okay, so then within this fretboard setup, I've got my 5 tool paths. So let's just look at these quickly. The first one are these index holes. So basically what's going to happen here, I'll make that visible. I've got a narrow bit that's going to come down and make a 1/16 of an inch hole here, and another hole here. And then I'm just going to stick some side fret marker plastic in there to index the fretboard to the neck when it gets glued to the neck. So that's what those holes are all about. And you'll notice that they're actually put in the center of the 24th fret and the 1st fret, and then the top of the fret is actually going to cover that hole. So it works out pretty well. Next, we're going to cut our inlays. The reason for cutting the inlays now before radiusing the top is these inlays are going to be filled with epoxy. I'll let the epoxy dry, and then I'll go ahead and cut the radius, which will, knock off the top. We'll make the epoxy at the same radius as the rest of the fretboard. But before doing the radiusing, I'm going to do a contour around the outside. So the actual final cut around the outside of the fretboard. The reason for doing that before the radiusing is that will give the bit, when you're doing the very edges of the radiusing, somewhere to go without colliding with the stock. Next, I'm going to do the finishing operation, essentially the radiusing. And lastly, I'm going to do the fret slots. And the trick about the fret slots is the bottom of that fret slot is actually the same radius as the top of the fretboard. So you may think that that's easy enough to do. We'll just select this slot and do a pocket operation. But that's not going to work because Fusion sees the bit size and the slot size being the same and generates an empty toolpath. So we're going to end up doing a trace toolpath for both the fret slots and the inlays. So we need some additional sketches for these toolpaths to work properly. So I'm going to go back to the design side of things, and I'll turn off our analysis here. So I've already done a couple of sketches here because they were used on the cam side, but I want to show you how to make these sketches. So I'm going to rewind the timeline and actually delete those two sketches. And another thing I'm going to do is I'm going to, let's see, this is the way the model was when we last left it. And there was a surface body that I removed here in the timeline. And the reason I don't do deletes, I do removes, is you can do stuff like what I'm about to do. I can right click on this and suppress the feature. So I'm suppressing the deletion or the removal of this surface body. So now that surface body is back in the model and I can use it. And I want to use it because that's essentially the bottom of our fret slot. This is an arched surface, the same radius as our fretboard. So we are going to make a sketch that has these fret slots in it, but they're going to be draped down onto this radiused surface. So I want to create a sketch, and it really doesn't matter where that sketch is going to be, but I do want to put it in my fretboard component. So that's activated. I'm going to do a create sketch. I'm actually just going to click on one of these sketch lines. This is going to be a 3D sketch. I didn't go over here and turn 3D sketch on, and I'll tell you why in a second. Let's go ahead and rotate the fretboard up like this, kind of get it back to where we were. Okay. I am looking at the slots sketch right here, and what I want to do is there's 24 of these fret slots. I want to drape that sketch or those lines down onto this curved surface. So there's a feature here in Project Include. It's called Project to Surface. And the first thing you select is the actual surface that you want to project to, which doesn't have to be a flat surface, and that's why we're using this. It's not. Now I'm going to select my curves, essentially lines. I'm going to go ahead and hide this body so that we can see those fret markers, essentially. I shouldn't say markers, fret slots. So I'm going to select all 24 of these, and I will verify in the dialog box before I OK out of this that I've got 24 of these. We are up to 21. There's 24. I don't want to select this one. This one's at the nut. Okay. So now our projection type we want to be along a vector, which it is. It may come up with this closest point by default, but you want a long vector. And we conveniently have the origin displayed here, so I can click on my Z, and you can see these red lines are what's getting projected down to the surface. So that's perfect. I'm going to go ahead and do an OK. All right, and now let's scroll up. Well, let's go ahead and finish the sketch. So this is the sketch we just generated. So I'm going to click and second click on that, slow double click. And I'm going to call this fret trace. Okay, so those are going to be our tool paths essentially. We're going to tell Fusion to cut at the bottom of the slot, but we can do it in a number of steps down because it's a tiny little bit. Okay, we want to do the same thing for our inlays. Remember, we only did 2 of those. So I'm going to hide everything but our inlays. Let's see, what else do I have showing here? Okay, there we go. So these are our inlay sketches. All right. So again, I'm going to show this arched body, and I want to project those inlay sketches onto this curved surface. I think those inlays were on the bottom of the fretboard. I don't quite remember why they were, but that's where they are here. So I'm going to create a sketch. Again, this is going to be 3D, so it doesn't matter what I select here. So I'm just going to click on something. Okay. Kind of got us misoriented here, but let's spin around. See our inlays. Okay, so we're looking at the bottom of the fretboard, and I want to go back to that same feature, project include, project to surface, and this is the surface right here I want to project to. I want to select all my curves, which are all these pieces of the inlay. So let me hide the surface body so that we can see those. So I'm going to go down to select curves and make sure I get all of these pieces. So I'm getting the clouds and all the rays coming out from the sun. And I might as well do this for all of the inlays at once. So here's the second inlay that we did. Okay. So our projection, we want to go along vector, and we want to project, select the direction. Again, we'll pick the z-axis here. And if we turn our body on, we can see that the inlay artwork is being successfully projected onto that curved surface. So I'm going to click OK. And now let's hide everything except for our sketches, our trace sketches. And this one we haven't named yet, so I'm going to call this inlay trace. Okay. So kind of hard to see, but those actually have an arch to them. And this is not quite essential, but I figure if your inlay goes out towards the edge of the fretboard, you don't have to worry about how deep you did it. The depth of this inlay is going to be the same depth regardless of where it is, even if it's close to the edge, because it matches the fretboard radius. So let's turn our fretboard on, and you can see we've got this sketch somewhere down in the fretboard. Let's turn the second trace on. Okay. So I think we can finish our sketch, and we can go back to the manufacturer side of things. Now, since we've modified our model, we should right-click on our fretboard setup and generate. And you can see there's at least one error here. It doesn't like the inlays. Probably because I renamed the sketch. I probably used a different name for the sketch. But anyway, we want to go through these one at a time. So you can see the setup is reporting an error, saying that there's one or more errors below here. And we'll take on this error as we go. But first, let's look at the index holes. So I'm going to double click on this and show you what this is. So this is a drilling operation. I'm using a 1/16 of an inch bit. And let's see what else is relevant here. We want to select our holes. So you can see these two holes here are selected. Let me go ahead and turn off some of these sketches that are kind of getting in our way. Let's see, fretboard, I'm going to hide all the fretboard sketches for now. And I'm going to hide our two inlay bodies, and I'm going to hide this body too. Okay, so now we can better see the two holes that are being drilled. Our heights, basically we want to start at the top of the hole, and our bottom height, I'm actually going to go 5 thou below the bottom of the hole just to make sure it goes all the way through. And in cycle, we're going to do a full retract. So it's going to come down a little bit, peck away at it, and then retract all the way. So if we do a simulate on this, again, green is already surfaced. The only reason we're seeing some green here is because there's such little radius here that Fusion is kind of estimating that very little gets cut here. But let me go ahead and simulate. Well, we're way too fast here. Okay, let's start that again. So here you can see the peck operation where it's coming down a little bit at a time and doing a full retract. I figure why not be safe? It's a very short operation. And it's going down to the other index hole down here. Here it comes. Should speed this up a little bit. And doing the peck operation there. So again, those are our index holes so that we can position the fretboard onto the neck during gluing. All right, so we'll exit that simulation. Let me close up some of this stuff here. Okay, so the next thing up are our inlays, which we have an error in right now. So let's go ahead and fix that. So I'm going to double click on inlay. It's saying, do you want to clear out all these operations? I always say no here because I want to know what I did last time. And you'll see the error. In this dotted area, it's saying, okay, you really don't have anything selected here. So what I want to do, especially if you had all of these inlays defined, I want to do a selection from a sketch. So I'm going to kill this, and I want to go to my manufacturing model, and I want to open up our main model that we have on the design side and go down to sketches and actually pick a sketch in here. So here is our inlay trace. So I'm going to click on that, and you'll see I've got sketch profile selected, and you'll see them right here. And let's do an OK. And that fixed the error. So now when we simulate, let's see what goes on here. So you see it's cutting little sections of this inlay, but it's doing it in multiple passes because this is a tiny little bit and you don't want to take much off at a time. And once this simulation, well, I'm going to go ahead and go to the end here because it's going to cut, both of these inlays. And let's take a look when we go back into this toolpath. We've got the geometry selected. The heights really don't matter here because this is a trace and we're telling it exactly where to cut. But we can do passes to get down to where we want to cut. So I had 7 step downs. 7 I just arbitrarily picked. I thought that was enough, but it's not doing 7. I think it's just doing 4. But the critical number here is the maximum step down, which I got from a little bit of research online for this 0.023 bit that I'm using. You really shouldn't cut more than 12 thou at a time. So I want multiple depths on, I want to set this number, and then this number can be set high. And let's go ahead and do it again, and you will see 2, 3, 1, 2. Oh, it's actually cutting in multiple directions too. So it's actually 1, 2, 3, 4. Yeah, okay. So it still is doing, you know, a fourth of that overall depth at a time. Okay. So that's how you cut the inlays. So at this point, I would fill all these inlays with epoxy. I like to use a black epoxy on a maple neck or maple fretboard. Next, I'm going to do the contour. So the contour is pretty simple. I'm just going to pick the contour of the neck, and it's just going to cut around the outside of it. The height, I'm going to go down to 0, starting at stock top. And passes, again, I'm going to be pretty conservative here. I'm going to do multiple depths and just do a 0.09 step down. I'm not sure why I picked that amount, but it looks sufficient here where it's not going to all get cut at once. So let's just simulate that. And by the way, I use double-sided tape to hold down fretboards and other pieces too. So you don't have any clamps in the way. So you can cut this without any tabs, which is great. Okay, so now we're going to get into the radiusing. And all I did here was a parallel toolpath. And I'm using a ball nose bit for the geometry. Let me open this up a little bit. For the geometry, what I did was I picked a machining boundary of a selection. So I can go in and select where to keep this within. Either of these, you know, would have worked there. And then I'm going to tool center on boundary, which is going to allow the tool to go beyond the edges here to finish this thing off. And this is pretty important, contact point boundary, having that turned on so that this bit can dip down over the radius and stay in contact with it. Heights really don't matter here. Passes, we're just doing a single pass because it's really not taking off that much. So let's go ahead and simulate this. Cannot simulate. Well, I guess I need to regenerate this path. Let's see what's happening here. Getting a warning, no passes to link empty toolpath. So let's see, I think I screwed the geometry up here. If I go into selection, I'm going to pick this bottom and then just do an OK. And that generated OK. All right. So I'm going to simulate. And now you can see that blue area is being cut back to green, which is exposing the model. So once all of these toolpaths are done, we should see all green here. And again, the nice thing here is even if you slobbered your epoxy, this ball nose is going to come around and finish that off at the radius of the fretboard. Okay, so I'm going to exit that simulation. And the last thing we're going to do is the fret slots. So let me double click on that. This is another trace operation like the inlays. The important thing here is to go to geometry, and if I clear this out, we are going to actually select a sketch that's got all of this geometry in it so that we don't have to individually click on sketch lines. So in order to do that, if I click on select, I can go to my inlay trace, and it's going to select it all at once. Heights don't matter here. Passes, same thing. We did the small step down. I think it was slightly different in the fret step down. I don't think it's going to end up doing 7 here, but I'll do an OK. And then let's simulate this. Let me slow it down here on this other one. So basically, the sketch that we did was the bottom of this cut, and then we did multiple step downs in order to get there so we don't break the bit off. So basically, that's it. this is, I've found to be a nice approach. Doesn't require much finishing around the epoxy. It's nicely cut by the radiusing. And the order of operations give you a chance to fill the epoxy in there. So I hope that works out for you. Let me know in the comments if you've tried this and how it worked for you. And I will see you in the next video.